Hello, everyone. I am Aapo Alasuutari. I work at Valmet. Did I actually? No, I didn't have a slide about that. Yeah, I work at Valmet Automation, and it might sound like I would be talking to you about something like bare metal or some cool real programming, but no, you've been led astray. This is now a TypeScript JavaScript conference. Be very afraid. I'm going to talk about foreign function interfaces, and Rust, somewhat Rust FFI, but mainly Deno FFI, and then some hairy details if we have time for. So what is foreign function interface? In a nutshell, interfacing between code, your code, and then some code written in a foreign language, or another language, usually linked statically, or maybe dynamically, or maybe truly dynamically, whatever that means. Anyone know what truly dynamic foreign function interfaces mean? No, of course not, because I made that up. Often you would think that binding two different languages together would be just simple. Like there's this native language function here, and you call it, and it works. Kind of, but you have different paradigms between languages. Like calling C from Haskell is probably gonna be kinda iffy, and so forth. So there's often more to it than just having functions that you directly call. Some common issues to ponder is how do you pass complex data through a foreign function interface layer? Like numbers are simple. U32, okay, I know what a 32-bit integer is. Some things that are not so simple, Booleans, because C doesn't have an actual Boolean, so fuck that. And of course, like really complex stuff like structs and can be kind of complex and whatever. Then who owns a memory? Who owns a buffer of memory? You've allocated 32 bits of memory in a heap. Who owns that? And what does that ownership actually mean? Like, I think there are kind of two meanings to that. Also, especially with Rust, what is safe in an FFI layer, and how much unsafe is okay? How much unsafe is too much unsafe? Of course, usually we're working on a C calling convention at its core. Though I guess with the real-time operating systems we've been hearing about today, it might not be C calling convention. I'm not quite sure. Though I need to give an honorable mention to C++ because the sysv ABI actually mentions C++ structs or objects specifically in the calling convention part, which is really weird. Like this is supposed to be like architecture stuff, and there's a language here, whatever. Okay, Rust FFI. If you've not yet gathered, I'm actually not an expert. I've dabbled around, but I can be wrong a lot. So, in Rust FFI, if you're writing a dynamic library, you will be declaring your external functions and statics with the extern keyword. And Rust will tell you if you're doing something wrong, like trying to use a string, Rust string in FFI, because that's not FFI safe. And you can write Rust dynamic libraries, and then strings and stuff are okay. But if you're doing C libraries, then of course strings are not okay. So I'm talking about FFI strictly in the kind of C or generic FFI slice or style. But I'm not really interested in writing FFI libraries. I'm interested in using them. So mainly I talk about linking libraries, statically or dynamically. Maybe it's written in C or C++, or it can be written in Rust. You have some library that you're linking to. In this case, in Rust, you use the external blocks, where you declare, okay, I have this external C function, C library and it has these functions, these statics, whatever, and you tell what kind of types they take. Then you explain to Rust or the compiler how you want it to be linked. Is it static or dynamic? And then you compile your code and everything is fine and dandy. And you've written that this particular C library returns a Rust string. Okay, the compiler is probably going to say, like, are you really sure that's really not FFI safe? But theoretically, you can do that. Is it actually going to return a Rust string? Probably not. It's probably returning a const char pointer. But who actually decides the signature that you write, the types that you write there? It's you. You write. You tell what this function does, what it takes, what it returns. You tell what this particular static or constant in that external library has. When you're linking to a library, the linking does verify that the function or the static actually exists. That is verified. But how many parameters the function takes, what types it takes, what it returns, there's no check for that. You either get it correctly or you make some fun mistakes. Then, of course, you can do dynamic linking at compile time, or you can do dynamic linking dynamically with, for instance, libloading, the Rust crate. There you can do so that you give a name or file path to a dynamic library, and then you explain which symbols, so functions or statics, you want to take out of that library. And again, when you're loading those, you by using the type parameters, you explain what this particular symbol actually is. If you do it wrong, it's fun. If you do it right, you get something usable. This is Rust FFI in a nutshell, I think. No comments, hopefully. But what about truly dynamic library loading? So what is truly dynamic? With Rust, we need to tell the types. We need to say at compile time, this is the type that I'm going to take. At least I'm not aware of any. Well, okay, maybe there might be ways to do it like really truly dynamically in plain Rust, but no. We're going to do it really dynamically. And this is where we get to the TypeScript stuff. There's a JavaScript runtime called Deno. So that's not Node, but in the proper order, you just arrange the letters in alphabetical order and it becomes Deno. It's written in Rust, the runtime part. The engine is the V8 JavaScript engine written by Google or by the good folks at Google. Same stuff that runs Node.js and Chromium browsers. And Deno has its own FFI. Instead of having a pre-compiled add-on surface inside the executable that then you load libraries that would then use those APIs, it provides a JavaScript-based FFI API. So Deno starts up, some JavaScript code gets run, and that code says, hey, I want you to load this particular dynamic library, and from that library, please open these symbols, and the types that those symbols have are these. So that's truly dynamic. Deno, Rust doesn't know what it's loading, what it's going to load, if it's going to load anything at all. And especially, it does not know the types. It cannot say this is going to be a function taking 2 parameters. So we can't do that with libloading. We need to use libffi. Libffi is itself a foreign function interface library or a C library available through a Rust crate. And it provides a declarative API for loading FFI libraries and getting their symbols and so on. It also has some great features like creating C callbacks. So like C++, you have callbacks, Rust, you have lambdas, and so on. But what about C? Yes, we can do that if we write assembly, and that's what libffi does for us. So what happens with Deno FFI is that the user code says, please load this function from this library. It takes 2 pointers and returns a pointer. Deno calls into libffi, says, please open this library, open this symbol from it. It's a function that takes 2 pointers and returns a pointer. libffi does some magic assembly stuff and gives a callable pointer with the proper types for Rust code, which is then kind of given to the JavaScript code, like this is what you want to call eventually. So it becomes this kind of weird stack of all kinds of languages. But you could kind of guess from this. There's JavaScript, Rust, actually JavaScript, C++, Rust, assembly, back to Rust, back to JavaScript. It sounds slow, right? Can't be fast. Luckily, V8 has this, the V8 engine has this fun thing called fast API. When JavaScript is being run, it gets compiled down to like actually very simple, very, very basic stuff. Eventually it gets all the way down to assembly in some cases. And the V8 has this fast API where when you're giving a binding function, when you're dealing with a JavaScript call from Rust, you get a generic object where you can query for the parameters that the JavaScript caller gave. Because of course, you can't interface directly between JavaScript and Rust, right? Rust only takes, you need to know how many parameters you have, what those types are, and so forth. JavaScript, there's no such thing. You call any function with any parameters. So it does not compute. So the Rust call that gets called when a JavaScript call is made into Rust just has one parameter that can be queried. Okay, how many parameters do I have? What are the types, and so forth. But that's horribly slow. So see, the V8 engine also has this extra layer called the fast API, where when you're giving your generic binding function, you can give another binding function and the types for that. You say this particular function takes 2 U32s and returns a U32. Please, V8 engine, if you're about to call this particular function using 2 numbers that are at most U32 and they need to be integers, then call this function directly. And V8 will eventually do that. Now, this then gets worked into the FFI quite nicely because C APIs are usually pretty simple. There's unfortunately some parts that are not quite simple and not some stuff that the V8 Fast API doesn't support. So the Deno Rust code has yet another, Rust side has yet another little extra thing going on for it. There's a wonderful crate in the Rust ecosystem called Dynasm RT, which is used to write trampoline functions in the fast call path. This is a crate for writing dynamic assembly at runtime, as the name suggests. So there's some stuff that the V8 Fast API does that we don't care in a C API. For instance, it always gives an extra 0th parameter that is relevant to JavaScript, but not really relevant to a C API. So we need to get rid of that, but the calls need to be specified, so it needs to be essentially JIT code, kind of. Dynasm RT is really useful for this. How many have heard of this? Maybe? Nope. Nope. Really good stuff. It's wonderful to work with, at least from what I've seen. And with this, we get to a situation where JavaScript code gets compiled down to essentially assembly. That jumps to our fast API call, which we've written using Dynasm RT as assembly. That then jumps to the actual C API call. And we get a very freaking fast foreign function interface in Deno, thanks to, in many parts to, okay, there's of course V8 to thank, but also the Rust ecosystem with Dynasm RT and so on. Gets very close to native level speeds, 3 to 4 nanosecond baseline performance. This is pretty fun stuff. And this is, by the way, I'm here mainly because I've been collaborating or contributing to the Deno runtime, writing a lot of the FFI stuff. But now we have an FFI system with a JavaScript runtime, and we find all the same stuff that I kind of mentioned here in the beginning about FFI, common issues to ponder. We're going to ponder the same stuff. How to pass actually any data. We're talking about JavaScript, the anathema of any like real programmer. So earlier I said that numbers are simple. Well, sort of, kind of. JavaScript has a single number type, the same floating number type that Rust has, F32, F64, or F64 specifically. So, okay, passing floating points should be simple. We just pass the number value. But what about like U32s? Simple enough, because you can fit a U32 inside an F64 kind of without the F64 losing anything, losing any information. So that's what V8 does for us, and it supports that. But if we need to use 64-bit integers in our FFI, now already JavaScript gets in the way, because the F64 cannot, of course, represent all the same numbers that a 64-bit integer can. Or, well, it could, but then the number in the JavaScript world would be horribly mangled. I remember Rust F64 and U64 have these lovely APIs that can be used to transfer one to the other bitwise. So you can kind of mangle your 64-bit integer into an F64, or kind of represent it as one. Yeah. So we get some numbers at least. But what about actually memory, passing memory? JavaScript has a thing called array buffers. It's essentially just linear memory. You can say, please give me 32 bytes of linear memory. And we can kind of get the pointer to that and pass it along. But the other way around, when we get memory from C, we get some pointer, then that's just a number for us, because there's no pointer type in JavaScript. It doesn't need pointers. So things get a bit hairy when you have two different pointer types. You have your own buffers, and then you have pointer numbers. Especially pointer numbers, that's icky, because any number is a pointer now. Also structs. Structs in CABI. Today I thought about this more, and I kind of like them. I understand the point. It's okay. If you're writing FFI stuff and you need to use structs, return structs, then do so. Don't do it to me. ownership of memory is still a big question, and now I'm going to go a bit more to the point of two meanings for ownership. First meaning of ownership is usually who should call the drop function. That's probably in Rust what you think about with ownership. If you're passing a string around, the last one to get it should drop it, right? And it's simple enough. But there's another meaning that I understand with ownership, specifically when you're thinking about allocated memory, which is who should actually deallocate the memory. And this, with FFI, it becomes a relevant question. Say you've allocated your C string in Rust. That actually, I guess, since it's supposed to be FFI safe, I guess it is, but if you're just passing a C string pointer or some memory buffer pointer through an FFI layer to, say, C++, and the C++ code accepts that pointer and thinks, I now own whatever is at the other end, and it knows what is on the other end. Maybe it knows it's 32 bytes of memory. It will then call dealloc eventually for that. And now C++ is deallocing memory allocated by Rust. They don't use the same allocator, and you're going to have a bad time, or maybe a fun time. I'm actually not quite sure how badly the program fails, or if it just does weird things. But this is a relevant question with FFI, relevant thing to ponder about. You can't just take pointers and believe that you should now deallocate the memory. So using from raw parts for FFI is usually a bad idea, unless you're really, really sure what this pointer is. With JavaScript, this is even funnier. So JavaScript has the array buffers. Oh.
Sorry, could you explain why the two aspects are different? Because I didn't see drop and deallocate.
So okay, deallocating means going to the system call to actually dealloc, whereas dropping would be just calling some function that does the deallocing. So if you send a pointer to C++, and you somehow tell the C++ code that when you're done with this pointer, please call this function, and that function gets the pointer, then does from raw parts. Now you're essentially implementing the drop function kind of at FFI level. So C++ can send you a signal saying, please dealloc this. This is fine, and this is kind of giving C++ ownership of the pointer, but not of the memory, or ownership of the thing that the pointer points to, but not of the memory allocated. Yeah, does that answer the question? Yeah. Yeah. So JavaScript has the array buffers, and additionally, with Deno, we implement an API where we can actually create an array buffer from a foreign memory pointer, but we just say we don't own this memory. Please don't deallocate it at the end. So when we're sending an array buffer to foreign code, we need to be really, really clear, and it actually kind of becomes very, very obvious for a JavaScript developer that the ownership never ever leaves. JavaScript will very happily forget about the array buffer if you just let it be alone there, and it will drop it. The native code will get the pointer, and maybe it stores it somewhere. It's keeping it for a better day. A couple of days later, it'll come back asking for it. But JavaScript has already forgotten about the array buffer. It has deallocated the memory, And when the native code finally uses the pointer, it will see garbage, and you have a very bad time again. This is really kind of fun stuff to work with from a JavaScript developer or TypeScript developer point of view. Of course, the other way around is also quite fun. As said, foreign pointers are, for Deno, currently just numbers. So you get a C string pointer, and we have an API that gives you the string from a C string. And then you think, okay, I got this number, but what if I call that function with, I don't know, some random number? Like, let's just generate a random number and call that with or call the get C string function with that number. You might get anything. Yeah, it's fun. And whether or not that number that you actually got from a foreign function code, the pointer, if it carries ownership or not, is also fairly interesting and hard to tell often. Should I or should I not call some drop function when I'm done with this? Hopefully it's documented well. Of course, from Deno perspective, the Rust backend of Deno cannot know if this pointer should carry ownership or not. It's all just void pointers to us. So this is all left to the user, essentially. The safety is also quite interesting and quite a convoluted thing with Deno. I'm actually gonna skip this part because I think the time is limited.
I think we are good so far.
Yeah.
Technically, you have 25 minutes from now on.
So,
let's leave room for random socializing.
Yeah, we'll be here until tomorrow. Yeah. So the FFI, Deno itself, and JavaScript is pretty much a sandbox. Node just completely f's that up. Deno tries to not to, but FFI, of course, leaves the JavaScript sandbox. You go into native code and you do whatever, God willing. We offer a way to close the door. Say, okay, I've now done my work with FFI, or I've opened essentially the doors that I need to. Please close the door for opening more doors. But since, as said, we have the pointers being just numbers, if you leave some of those doors that you opened open to users, if you give your users as a library developer the APIs that take just pointer numbers, and they can use them, they can probably get memory corruption out of that, and with a well enough coordinated memory corruption, you can get exploits. So yeah, FFI is really cool, especially in JavaScript, and it's also a very bad idea, which is why I love doing it. Some hairy details. This is my personal view on FFI from the stuff that I've worked on. Namely, I've worked on one internal C++ library binding to that, and then I've recently been working on libclang, the C API library. And from these, first of all, what I've learned is that structs are a pain when passed by value. For Rust, this is actually very common. Like, we send strings and vectors here and there. Maybe sometimes we'll say it's a borrowed value or can be a borrowed value, but in C APIs, in foreign function APIs, my personal opinion, it can be useful, but by God, I've seen C structs returned by value which then require calling a drop function. That makes no effing sense for me. You obviously have something in the heap allocated for this particular struct. Now, why are you returning it to me by value? I hate that. Don't do that, please. Not to me. Though it often is faster. The pain in struct passing is mainly that you actually need to know what you're passing to get it right. And it's very easy to get it wrong. There are a lot of architectures that have their own rules, and sometimes you just make a mistake. Fun example, the Google V8 fast API, they actually have the wrong calling convention for stack value passing of stack value passing of essentially any data on the stack. It's just wrong. They can't fix it. It's too hard. So they currently have disabled it altogether. Another thing, binding directly to C++ is wonderful and a wonderland of pain. In Rust FFI, when you're doing your extern block and you say this is an extern function, you can tell what the name is. So you can do aliasing, but it can also just be used for demangling. So if you have a C++ dynamic library or static library, you can bind to it with the extern blocks, giving the name in an attribute explaining that this is the C++ mangled name. How do you get those mangled names? Well, hopefully there are many tools for it, but you can also do the nm output and manually find that function you're looking for and then copy the mangled name and put it into your library. I've done that a lot. It's quite fun. And also the other fun thing with C++ binding, direct C++ binding, is the sysv ABI. So there's this, more or less this exact phrase in the spec. If a C++ object is non-trivial for the purposes of calls, it is passed by invisible reference. So that means if you have a copy constructor or a destructor that is non-empty, not empty, I think, then any pass by value is actually pass by reference. It also means that if you are returning by value, then you're actually returning by the 0th parameter. So there's actually an extra parameter which is a out pointer. So binding from Rust to C++, where return by value is done a lot, means that you need to do a lot of maybe uninit code for out pointers. Also, C++, like Rust, has a lot of FFI incompatible. Yes, I had to search this word while I was writing this, and now I had to search it again. So a lot of FFI incompatible types. The lambdas std function is my favorite one here. I've tried to make it work. I've done some like assembly decompiling, trying to figure out like, okay, what's the point? But it's always too much of a pain. Easier to do some manual extra binding. Also, I think standard string is likewise not FFI compatible. So if you find a way to bind from Rust to C++ using std functions, please let me know. I really want to do that, but has been too much of a pain for now. But honestly, it's very fun. And then final point, if you're ever doing a C API library, please make it wildly inconsistent and please document it very badly. The libclang C API is kind of a good example with this. It's not like horrible, but it has its inconsistencies. So it has a lot of return by value stuff. A lot of structs, let's say 3 to 4 pointers in size, are returned by value, which I mean is fine, I guess. But then there are some that are returned by pointer. And they're like exactly the same stuff. Like, honestly, you look at them side by side, and it's the same data. You're passing the same data. Why is one of these passed by value and another by passed by reference? There's no obvious reason for it. They both require dropping. They both require manual memory collection and so forth. It seems to be just a personal preference of whoever was writing the C API at the time. Please don't do this. Pick one, stick with it. Also documenting your API. This is of course generic programming advice, but be explicit. libclang often uses the phrase should be released, which is okay. I would perhaps use must be released, but anyway. But then when it doesn't need to be, they use does not need to be released. So can I still release it? I'm not sure. I haven't tried yet. I'll see if it explodes. Also, for some nice reason, the CLang API, which says that it tries to be maximally backwards compatible, does not have any way that I've seen to document when a particular API was added, when it was changed, or anything like that. So I've just been going through the index files and then trying which symbols are not in the library that I have. There are some, yes. Also, internal dependencies between objects. Please document those. Really, if releasing object A makes B segfault, document it, mention it. None of these are usually done, I guess, and as a result, developing an FFI library is really much Indiana Jones-like work. You try something, with wobbly hands, you move a pointer, and it exploded, yes. Let's try again. Maybe this is actually passed by struct. Yes it is. I had misread the documentation, yes. Yep. That's my presentation, couple of links. There's my GitHub where you can see my wobbly attempts at writing FFI code. I also have it in a tab here if you want to see more. And also I have written a Rust-nomicon-esque Deno-nomicon for the Deno FFI, containing all of the hairy details and the ugliness and fun that is FFI from JavaScript. So, any questions or comments or?
So, on the first slide, you mentioned that you've got some super simple and trivial types like U32, and everyone knows what a U32 is. And it's like a good idea that you have, like in your types, you type in what the bit width of the type is, and that makes the FFI a lot simpler. Well, an issue or a pull request an issue in Rust-lang repository. It was a complaint about the 128-bit integer not being compatible with the C128-bit integer. So I'm not sure which one managed to underspecify which, but this is concerning to me. This is not a question, but thanks for answering.
Yeah, I have looked at the same issue. Luckily, in Deno FFI, we don't support higher than 64-bit integers yet. But once you go beyond the 6 basic types, I think every language has its own peculiarities. Like, I love the fact that there is no actual real Boolean type in C. Like, there is, but it's just nobody wants to use it because it's not defined, I think, before some year and whatnot. Yeah.
Thanks. I was thinking, have you tried hot reloading of JavaScript libraries from Rust? Like you load it first, and then you change something in the code, and then you want that. Okay, I didn't change anything on the Rust side, and I know this is safe. I'm gonna reload the JavaScript library to get the new functionality into use.
So Deno, I have never tried building my own kind of JavaScript runtime on top of the Deno crates. By the way, the Deno runtime environment and everything, crates are available in crates IO. So I've never really played with that, and Deno does not offer a way for kind of unloading a module and then reloading it as a new version. So can't say I have, no.
Okay.
There was a question there.
Johanna.
I was almost ready to catch it, but thanks. So do crates like CSX or recently announced TypeSafe help in your job through FFI?
I'm not aware of those. They
For
might.
instance- Yeah, for instance, CSX, it's pretty rudimental, but there is an example of actually mapping a Rust string to whatever in C land is CXX by Bernd.
Oh
Sushi.
yeah. Sorry, CXX. Yeah. This is one of the tools that I sort of kind of referred to in the binding to C++. I didn't mention it in the talk, but automatic tool that may or may not work. So I tried CXX and I tried the other one, can't remember the name of it right now, and I could not get them to work. But yeah, those, if they work, they're probably good.
Here's another one just for you. I don't know. I've read about it today. I think it was recently announced, and it's already 1.0 version even from 1Password. That's called TypeShare. And what's, I guess, pretty remarkable in their case is they're talking about structs being serialized back and forth to, well, whatever TypeScript structs are.
Yeah,
Could be useful.
yeah, seems interesting. Yeah. Any other questions, comments? Any riots about? Yeah.
You mentioned passing lambdas and std function through an FFI. Can you give an example of why would you do that? It's a thought that makes my head spin a little bit.
So my reason is not good at all, but basically at my work I work peripherally with a C++ library that is meant only for writing other C++ applications that then dynamically link to it. And I would like to link to it from Deno. But unfortunately, a lot of its APIs use lambdas. So like it would be nice for me to find a reasonable and relatively safe-ish way to build C++ lambdas in essentially raw code.
Thank you. Good that you're having fun with that.
Yes, it has been quite the fun thing. Yeah, I'll end this by showing some of the Deno FFI code for my libclang project. So this is essentially what the Deno FFI looks like.
Can you make it bigger?
Yeah, I guess I can. I have copied over the comments from libclang, and then here I'm just exporting the definitions. These are input in another file into the actual DL open command. But so I'm saying that my Clang virtual file overlay set case sensitivity takes 2 parameters. I'm linking to some other definition and then int and result is a CX error code T, which happens to be a U32, I believe, or U8 maybe. This sort of stuff. And it somehow works. Let's see if I can get the... There's another file here. Eventually it then gets turned into some kind of JavaScript that kind of works. Okay. That's all from me.